guys. Good morning. Let me start by asking you guys a few questions. Has everyone here signed a smart contract interaction, like a transaction to, do a trade or do like something a little bit more advanced than just transferring Ethereum on the blockchain? Like hands up if you've already done that. Okay, good. So you know what we're talking about. Have you guys built dApps, like deployed web UIs or smart contracts, those kinds of things? No? Have you guys built wallets, like for signing transactions, any code that like actually interacts with private keys and has to show users like, okay, awesome, this is good. Cool, so this is gonna be relevant for you guys. I want to start with a little game here. Like, if you guys read this this UI here, does this look like something you guys would sign? It says, be kind and respectful to everyone. Like, that's good, right? Only share things that are nice. Like, okay, you guys would hit agree and continue? Yeah? Hands up if you agree. Well. Oh no, we didn't scroll down. There was something more. It says that you have no rights, and it says that you just sold your soul. So oops. So this is this is the kind of thing that happens in crypto all the time, right? Like you see a interface, it says you're about to do something, but do you really understand what you're signing up for? Do you really understand what you're signing with those private keys? So we are Viktor and Prasanna. I'm a founding engineer at Anchorage Digital. Prasanna is a blockchain researcher, and we work at this company, which is essentially doing a lot of different things, but primarily we store very valuable private keys and allow our clients to interact with the blockchain with those private keys. One signature could be extremely important, could be $1 million, could be $10 million, could be $100 million. When you have that kind of responsibility, we like really care about what our clients are signing. So we're going to look at the general architecture of the systems that we use every day to sign transactions. And then we're going to look at the usability of the user interfaces that display what we're about to sign. And then we'll talk about how to improve. So first of all, when you guys start signing, like doing anything with DeFi, interacting with smart contracts, first thing you pull out your laptop, you have maybe your desktop, I don't know, and it's running some sort of operating system that could have issues, that could have vulnerabilities. It's running some sort of browser that also could have vulnerabilities. You start adding more things to it to be able to get to those dApps. You have to trust the dApp front end that it's doing the right thing. It has a back end. These dApps, like sometimes they include JavaScript from other sources, from CDNs. You're running various browser extensions. This is sort of the attack surface that we're looking at here. If these things get compromised, then you might not be signing what you think you're signing, right? Like we don't want that to happen. And consider all the supply chains involved here. Like even with this simple example, multiply that by 10, 100, 1,000, because in order for someone to ship a dApp, they have to install whatever like random tool chain locally and curl to bash and whatever they need to do. All of these things are like massive attack vectors. And we've known this for a long time, and we've done things about it. Before we get into that, how many of you have heard of the Bybit hack that happened recently? Hands up. Okay, yeah. So long story short, $1.5 billion, biggest hack that's ever happened. And do you guys think that this required compromising like 10 layers of the operating system and like advanced technology and like years of like 0 days research and vulnerabilities and massive resources? Actually, the massive resources were deployed on the money laundering side. Like the actual hack was a little bit of JavaScript that was injected into the front end. That's all it really took because of the way that our interfaces work. So we'll see more about that. We already have tools that reduce this attack surface. So for example, if you're using something like MetaMask, you don't necessarily trust what the dApp is doing, right? The dApp proposes a transaction, and MetaMask would show you what you're about to sign, and then you sign it. So that's great. Like that reduces the attack surface. And if you're using a secure signing device, then that reduces the attack surface even more. So now you just trust your secure signing device, its supply chain, and so on. But this is only as secure as what your signing device shows. If your signing device shows some gibberish and you hit agree, your signing device is not really, like, you haven't really eliminated all those threats that we were looking at. Like, you're still vulnerable, and in the case of Bybit, we don't know the details of what signing devices they were using or so on, but we do know that a secure signing device didn't really save them. So let's see why.
Thanks, Victor. So let's look at the usability of the signing devices. So we have already talked about that the signing device is the most important part, but there are multiple ways to implement user interactions. Most wallets support some built-in mechanisms that I'm putting over here as known transactions. Like your wallet just knows how to do a withdrawal, how to do a transfer of ERC20 tokens or NFTs or whatever. You can restrict that input. However, if you're taking a input from a dApp, you have to really start looking at what you can actually show, and more often than not, what we actually end up in is what I call fallback here, which is just showing the hexadecimal for the user. And I'll go into this in further slides, but keep this picture in mind, where every wallet is essentially doing this kind of parsing, making some visual representation, and then deciding whether it can sign or not. I want to show an example of the Anchorage wallet itself, where we have integrated transactions like withdraw, staking, vote, etc., which are just built in. We just need to know what token you are trying to transfer, how much you are going to transfer. We don't need to trust any other source. We have reduced drastically the supply chain risks here. However, this is a fairly early version of what we built for parsing Uniswap transactions, and Uniswap gets very, very complex, where you are looking at a transaction, bunch of call data that you have to interpret, and most browsers, most wallets don't really do a great job of parsing that, and we have a couple of ideas here. So let's start from the bottom, where what do most browsers do? So this is another example, once again, from the Bybit hack, from research done by NCC Group on the deep dive. I have this hexadecimal string in red. Does that look kind of familiar to anybody here? Like, does this look like some string you have seen in the past, or when you're signing a transaction? Okay. Yeah, no, for dApp developers in particular. Okay, so this is what the users saw, and if you've stared at enough transactions, the first prefix, these 4 bytes, looks like a transfer. But just for fun, I put it into the 4-byte directory, which lets you do a reverse lookup. And that there are already a bunch of collisions, even for one of the most commonly used methods inside Ethereum. So this is not exactly what got compromised, but the idea is that we cannot really rely on our muscle memory or hunch to determine that something is safe. Just because we have seen this multiple times, it's very easy to get mistaken. So we have tried to build standards for this. EIP712 is one of those standards which is getting widely adopted, which allows you to define what your inputs are supposed to be and sign a string message itself in a structured way. And this is from the spec where it's very clear you're trying to interact with a mail contract, and Alice wants to send Bob a message, and it's a nice, human-friendly, readable way. In concept, in theory, it works really well. But going back to the Bybit hack, this is what, if they were using MetaMask, this is what they would have seen as an endorsement, where we are back to the same string over here that they have to interpret, and it was so hard for us to even know that what those 4 bytes were. How hard do you think it would be to parse that you are actually sending 1.5 billion in ETH or $10 in ETH when it's presented to you in a uint 256 string? So it becomes really, really hard in practice, even though in theory EIP712 should work. What is the next alternative? There are ABIs that stand for Application Binary Interface, and every contract has one. And usually most popular ones are deployed on Etherscan, but you may not even know whether that is the implementation of that address. It could be a proxy contract, and at that point, you don't know what kind of proxy contract it is. So here's another example of a contract, which is a 1-inch aggregator. And over here, like all these fields have some name to them. So it's called Uniswap, their source token, amount, min return. And when I get to over here, it's an array of byte 32, and I don't know what this means. You have to read the source code, and when you read the source code, it actually says it's a list of call data for Uniswap v2. But by just looking at ABI, users don't have a way to know what they are actually signing for. Who actually does know this? It's the dApp developers. Because they're writing this dApp, they have some interaction in mind, they have a user in mind. And we need to find a way for the dApp developers to be able to share this information in a way that wallets can actually interpret. There have been newer standards proposed, ERC7730 in particular by Ledger, which extends on this same idea, which is take something like EIP712, which lets you add the signing message and add some additional context to it. Here's a display format that you want to use, and they're currently using on their hardware wallet over here. However, this is a very new standard, and it doesn't support all interaction types, namely meta-transactions, user operations, which are really crucial for the growth of Ethereum, are not supported by this standard yet. It's very new. Not all dApps have adopted this standard, and also wallets. We only know one wallet that really ships, which is Ledger. And that really only leaves you with doing per dApp custom parsing, right? I could go for a long time for many different contracts, but I wanted to show a very popular contract with Uniswap, Universal Router, where even to parse a basic swap, you have to really understand how the first 8 bytes of your command are laid out, and then you interpret that, and that is custom. And you see that pattern a lot, which means each uint 256 needs to be parsed very, very differently to understand.
All right, so we just saw all these different ways to parse inputs. We're basically all implementing the same kind of stuff in wallets. And this is a general architecture of a wallet, right? We have the parsing of the input, turns it into some sort of visual representation to show to the user and sign it. So how do we do better at that little parsing piece that everyone has to do? Well, if you guys are dApp developers, there are things you can do to make your dApp more likely to work out, like to look better in those screens. You can start by making sure your ABI is uploaded to EtherScan, right? Like that's really important because we don't even know what is going on without having an ABI. You can improve your ABI. You can make it easier for a human to understand your method names, the inputs to those methods. And there are trade-offs there. I know that you might want to optimize for, low gas costs or other things, but do consider the risk that if no one can understand what's going on, then that could lead to some bad outcomes. Of course, using EIP 712, very, very good idea. Using contributing to the ERC 7730 registry also really helps. So anything you guys can do to make those dApps more likely to be shown by wallets well is a good idea. I would say like testing some wallets would help just to get a sense, but there are so many out there, so it's a little bit difficult. That being said, like on the wallet side, we should make sure we implement all those standards. Like these standards are good, they really help. They're not implemented everywhere equally, and every wallet is doing things a little bit differently. So actually, we want to encourage wallet developers to start working together a little bit more as well. Like we want like anyone that's working on a wallet to actually get in touch with us. We set up a Telegram group for you guys to join. Also talk to us after the talk. And we want to start some collaboration here because I don't want us to be competing for who's going to get hacked more or who's going to get hacked less. We should all have clear interfaces and we should work together to build this up. The security of our wallets is only as good as those UIs. Even after we've solved all the hard security problems, we've fixed all the bugs, we've done all those things, we don't want to end up in a situation where people are just blind signing and all of that was for nothing. So that's why you guys should talk to us. We'll try to coordinate some things. We have some ideas in mind already that we can't like share publicly yet. We need to refine them. So it is a little bit of early, but I think it's a great time because of the Bybit hack, because of all the things that are going on in the industry. We should start that collaboration now. So talk to us. Thank you.
All right, we have some time for questions. Hey.
First of all, great talk. And so I have a security background. I used to be a security auditor, and I was looking into this. Just first of all, really, really great talk, really in depth. What I'm finding challenging, especially on the Bybit hack one, because I think it was trying to fake a transfer, right? And then in one of the arguments was like pointed as one, which is becoming a delegate call. And kind of coming back to this actually is that I'm wondering how you're thinking of showing the meaning of the arguments. I think that's really challenging. Like the interface we can define and then kind of like agree. I can imagine that being like achievable, like through collaborations, of course, etc. But the meaning of the arguments, like especially the one I just mentioned, that's like pretty tough. And wonder if you guys have any thoughts on that? Yeah,
actually, are you already familiar with ERC 7730?
7730. I don't think so.
Okay, yeah, that's the one that we mentioned earlier. So with ERC 7730, we have a way to, like, there's a way to add additional information about what the arguments mean in addition to just like what their names are, right? So you can say like, this is this type of like address, maybe this address represents this or that. Like you can add additional information there. So that's one aspect. But there's another thing to consider, like in addition to all of the stuff that the wallets are doing in a sort of verifiable and provable way, there's transaction simulation, which can be really helpful. And that's a little bit of a different threat model. Like your hardware wallet by itself can't determine what the expected outcome of a transaction is, but you can run that simulation in your backend and then show it to the user to add to the like what they can see in a verifiable way as well.
Yeah, I totally agree on that because when I was experimenting with this, I was doing on the transaction simulation side. And then I found out that the transaction simulation, because it's too technical for users as well. And then there is like work you need to do to make it simpler so that user can like, some weird things are happening, etc.
Yeah, so there is like the, one of the things we think about a lot is that what is happening or what is going to happen on chain, like whether you derived it by simulating or by interpreting. The key thing to know is like whether it translates to what a user intends to do, right? So if the simulation ran and then it shows like these amounts, the token amounts don't match, right? That can be another layer of like showing what is like the most important thing you care about for this transaction. In this case, it was tokens, but in some other case, it could be a governance vote where you want to vote yes, but somebody changes it to no or something like that. And so we really need to figure out what is the key thing that we actually want to display, and whether it's simulation or through parsing, like we want to make that very prominent for the user so that they can make that decision very clearly. Like just showing more data doesn't really help if it's just noise again. Yeah.
Thank you.
Cool. Any more questions? Do you want to go back to the slide with the Telegram group? I think it's really nice that there's this intimate opportunity that everyone can participate. It's really nice. All right. Last questions. If not, then thanks to Prasanna and Viktor. I think safer signing means safer crypto. Love to see it. Thank you.
Thank you.